Hello, and welcome to the Open Systems Media webcast. Combine AI with the IoT to get AIoT. This webcast is sponsored by Axiom Tech, Interval Zero, and Micron. My name is Rich Nass, and I will be your moderator for today. I am also the Executive Vice President of Open Systems Media. I lead the content team for embedded computing design. If you are not familiar with that property, you'll find it is a great resource for anything related to the design of hardware and software for embedded systems. You can find it at www.embeddedcomputing.com. It's filled with design articles, white papers, blogs, videos, podcasts, and lots more. And that certainly includes AI, IoT, AIoT, and all that stuff, which is coming up pretty much in every conversation I have these days. So back to the topic at hand. This topic, AI and IoT and how it's combined, is one of the most popular things on our website. It seems like the design community just can't get enough of this. So on this webinar, where that's exactly what we'll be talking about, you'll hear from four experts. In order, they are Dave Starrett, the Vice President of the Eastern Regional Business Unit at Axiom Tech USA, Ricky Watts, the Senior Director of Intel's Internet of Things Group, Brian Calder, the Vice President of Sales for the Americas and the APAC region for Interval Zero, and Tafiq Ahmed, a Senior Manager at Micron. In the interest of time, I'm not going to read their bios, but if you look at your console, you can see their bios, read them at your leisure, and you'll see that they are experts in their field. Before I ask the first speaker to come out, let me go over some of the housekeeping items. I expect this entire presentation to last somewhere around 45 minutes, give or take a few, and that'll leave us some time to answer your questions, and we will get to as many as we have time for. You'll find on the console window, there's an area to ask your questions in real time. And as I said, we'll answer as many as we can when the four speakers are done. We tend to answer them in chronological order, so ask the questions as soon as you think of them. Don't wait until the speakers are done to put your question, because then we may not have time to get to it. If we do not have time to answer your question, someone will get back to you after the webcast is over. So every question will be answered, just maybe not as part of the webcast if we run out of time. You'll see on the console, there's a maximize button that allows you to see the slides in a larger window. And this webcast will be available in an archived version when we're done. So if you miss something, if you want to go back and review, if you want to forward it to a friend or a colleague, it will be there for you. Whew. Okay. Let's bring out the first speaker. That would be Dave Starrett of Axiom Tech USA. All yours, Dave. Take it away.
Rich, on behalf of Axiom Tech, I would like to thank our trusted partners who are participating in this webcast. Just a quick shout out. Axiom Tech has been an Intel titanium level partner now for over 15 years. We rely on them for technical guidance, market guidance, and marketing collaboration. Thank you, Intel. As far as Interval Zero, you'll find Axiom Tech on their partner page. There'll be a host of EtherCAT solutions that we've collaborated with Interval Zero on. Feel free to surf that particular site, partner site. And finally, Micron. We've been a partner, and Micron has been a supplier of Axiom Tech for over a decade. So again, not only do I want to thank the three partners who are participating in this, but if there are any partners that are dialing in, thank you very much. Without you, it'd be a very difficult task launching products. So as far as Axiom Tech and the tail of the tape, we're founded in 1990 in Taipei, Taiwan. We celebrated our 30th year in business last year. We have over 800 employees worldwide. We've got a global footprint of manufacturing and integration facilities in 8 countries as it stands right now. As far as here, drilling down into the United States, we have approximately 100 employees spread out over 2 locations. We got a facility in just about 20 miles east of LA in City of Industry that acts as our USA beachfront, USA headquarters. My particular business unit here on the East Coast is 20 miles north of Boston. In Methuen, we've got approximately 50 employees there. Both facilities function as a high value add system integration location, as well as a design center for our customers that like close proximity either on East Coast or West Coast. Axiom Tech is recognized most for its broad range of embedded and industrial boards, a lot of industry standard form factors, as well as our design engineering services. We go to market with both a direct sales force as well as a trusted national distribution channel. And also we supplement that with regional channel partners. As far as industries that we serve, we are heavy into medical, gaming, a lot of mission critical applications in the automation and process control, retail automation and transportation, just to name a few. I like to say planes, trains, automobiles, and everything in the middle, as long as it's mission critical. So that's Axiom Tech's tail of the tape. Take it away, Ricky.
Thanks, Dave. And again, just to add to that, truly valued partner with Axiom Tech, and thanks for the opportunity to come today and talk a little bit about artificial intelligence and its applications around Industry 4.0. Just before I get into the presentation, I got a little video that I'm going to share. I think it's a good way of showing some of the exciting things that AI is bringing to the world of industrial before I go through a few slides about what we've been doing together with Axiom Tech to bring this wonderful technology to the industrial market. So with that, I'll just play the quick video.
People are asking, what now? Well, now is what we've been building towards. Now is when we put our ingenuity to the test. Now we move forward into the next industrial revolution. At Intel, we've been creating solutions for industry's most complex problems. Solutions specifically built for the IoT age. Processors with breakthrough speed, high-performance computing, and AI deep learning capabilities integrated into a single IoT solutions platform. Enhanced software that can integrate multiple applications and gain insights at the edge in real time. And the world's strongest IoT ecosystem, with tens of thousands of intelligent edge deployments that help simplify technical complexities and speed up deployment. Right now, we can shape the next era of industry. Make it faster, smarter, safer, so that we're ready to take on the greatest challenges of our time now. This industrial revolution will be wonderful. And innovating together is how wonderful gets done.
Okay, well, I hope that was an insightful video as to the world of what's possible when we look at artificial intelligence and its implications into the industrial domain. And I guess just a few questions as I go through these slides: the why, the where, the how, and the what. So, artificial intelligence, why is it so important, and why is its fusion with the industrial Internet of Things so important? If I go back and I look at the legacy industrial environments, machines that were running, facilities, factories, etc., there was a lot of data that was locked up in those machines. In this industrial Internet of Things world, where we're now starting to connect things, devices, in a much different, more flexible way, these devices are generating data. How do we analyze that data? What do we want to do with that data? What does it drive? And that's where artificial intelligence comes in. It's what can we see, what can we access from that data as we bridge AI with IoT? What markets does it apply to? From an industrial perspective, I'd say AI applies pretty much everywhere. In the industrial context, Dave mentioned mission critical, factory operations, industrial facilities, in the energy market. How am I going to bring a sustainable world around where we're very much more aware of how we use energy? AI is going to infuse itself into all of those market segments as we go forward. And it's becoming an absolutely critical component of really what the industrial Internet of Things is going to. How am I going to go do that? How do I get access to that? Well, you've got to get solutions. And together with Axiom Tech, we've been defining that. Obviously, if you're going to run artificial intelligence, it needs to run on a platform. That platform's got to be suitable for the environment that it's going to be running in, at the factory level, at the utility level, in the control floor. So again, working with Axiom Tech, building this partnership around, hey, how can I fuse the right hardware platforms from Intel with the right software assets? And I'll talk a little bit about the software as well, because software is a critical component of how we do this. Fusing those things is two things together. And then one thing I would just add is, of course, every factory environment is relatively unique. So there's a services element to this as well, which Axiom Tech also bring to the table as well, which is how do you integrate it into your legacy systems as well? So again, I think I've captured that pretty well in terms of what we're doing here. AI together with IoT, how do we implement it and how do we make it work and useful for our end users and customers? And what are they going to go do with this thing? So let's look at some of the use cases that AI can impact. I'm not going to necessarily go through all of these. I talk about defect detection, predictive analytics. So where does AI fuse itself into this? Well, firstly, let's look at the data sets that we need to access. Different types of data, video data, unstructured data, time series data, audio data. This is all being generated in the factory environment now. So pulling that out, having a platform and a software layer to pull these things out, then what we're going to do with that data? Defect detection. It sounds pretty obvious. Hey, an example, I'm looking at a manufacturing process. Maybe they're cutting steel. They're doing final assembly. They're doing packaging. How do I know that process is optimized and is working to the best of its ability? Are there any errors? The worst thing you want as a manufacturer is to send faulty goods out into the supply chain. You want to capture that way up front. So using AI to analyze the data, looking at things that are going on, and then be able to recognize that and intercept that process in the manufacturing environment. Predictive analytics, another one. Machines are very complex in manufacturing environments. There's lots of machines, motion controllers, conveyor belts technology, robotics, all working together in harmony to deliver an end product. Well, those machines go wrong. So how do I look at those machines? How can I analyze data that those machines are sending out to understand, is something going to go wrong? If I can understand that and look at what the data is telling me off of the machine, I can minimize downtime and maximize uptime in my factory environment. I can do my machine maintenance in scheduled windows to avoid interruption to manufacturing processes. Again, so predictive analytics, defect detection, productivity overall, how are people interfacing to the equipment, where are they going, what things are going on. AI can be uniformly used across all aspects of industrial. And IoT was the impact that bringing AI and IoT together allowed us to do these things. So let's have a look at something I think is kind of interesting, which is machine vision. This is one of the areas where we're seeing a lot of uptake in early adoption of using AI. So, how do I bring in a machine vision into my manufacturing environment? I go back. So, it's about us as a community putting together a solution and a package with our partners that says, hey, we've got the right hardware platform that can say, in this case, take data that's coming off of a camera, analyze that data, how many frames per second, what am I looking at in the process environment, optimize together with a software engine that sits on top of that. And I'll cover that software engine in a minute. So software, hardware fused together, fixated around a specific application. I say we've seen many use cases of this. We've worked together with our partners around things such as welding, bottling, packaging, putting labels on things to make sure all of these processes can now be enhanced by using AI with a package that comes through a company like Axiom Tech, can install it relatively easy into the manufacturing environment with minimal interruption, and then have the output of that actually start to impact what you're doing in the environment as well. So again, machine vision solutions with Axiom Tech. Hey, you can start this on your journey when you start to look at how AI impacts IoT and really start to move in that direction as well. So I think this chart's important because I talked about the software aspect of this as well. So you've got to have great hardware. The hardware's got to be fit for the environment. It's got to be optimized to the type of data that you want to get out. But how do we make this easy? Industrial customers are not software experts. They're not AI experts. So we want to put a toolkit together, a kit. And we've been working together with our software elements that show our capabilities on our silicon, and then working with Axiom Tech to kind of like bring something together that says, hey, The hardware is optimized with a software layer on top of that, allows us to do these things called inference and training between edge to cloud. One of the things that we're seeing, is the data that's being generated is being generated at the edge, at the factory level. We can't afford to send that data up to the cloud. Sometimes it's too long. There may be regulations that are involved. So the data is being processed at the edge, near where the manufacturing environment, near where it's being used. So we want to do this thing called inference. We want to look for something in the data that tells us it's going to do an action. Now, what we're looking for is the training. The training has got to look at the data and tell the inference model how to do that. So we've got a package here together, hardware, software, to do this inference, all linked together so that you as a customer can actually start your journey pretty quickly. You've got all of the tools, all of the capabilities to go out there. And as I say, the last layer is really the services. How do you integrate it into your IT environment? Make sure that it works harmoniously with the other systems that you've got out there as well. So again, services, reference solution with software, ready to go to do things such as machine vision and other data sources as well. And I would say, just as an example of that, where we've worked, or Axiom Tech have worked, we often sometimes look at these things and think, oh, well, this is great for big companies. But we obviously want to get this technology into the hands of everyone. And MIDA and this deep learning solution that was put together for Asia Pacific and the Malaysian market was, how can I take it to enterprises that can take something off pat? Here's the hardware, here it goes. We got this unique user interface that developers and algorithm writers can go in and interface to immediately. So this is a way of accelerating not only within the factories, but the community of people who are getting involved in this as well. So small, medium businesses, institutions, getting that out into the market. So this is great innovation and getting it into the hands of all. So, I say in final conclusion for my presentation here is AIoT is real. It's coming together. It is, I think, the catalyst that drives the real benefit of IoT. Get started on this journey. Really clearly, you've got to, what are you trying to achieve? Where you're trying to go? Work with companies like Axiom Tech, who've been working together with Intel, that are going to allow you to accelerate your journey, start getting the benefits today, and then we're only going to evolve where AI starts to go as we start to get into a whole new level of how we use AI with things such as digital twins and much more integrated into the factory environment. So with that, I'd like to say thank you very much. And Brian, I'm going to hand it over to you. Thank you.
Thanks, Ricky. Afternoon, all. My name is Brian Calder. I am VP of Sales for a company called Interval Zero. More on what Interval Zero does in a few slides. I've been with Interval Zero for 13 plus years at this point and cover the Americas and APAC. And today I'm going to talk about best practices for implementing AI and vision for IoT. First up, just a couple of slides defining IoT and IoT and AI. IoT is not new. It's been around for a long time, a good number of years at this point. IIoT is more recent, and I pulled one definition that fits what I'm talking about rather nicely. So industrial Internet of Things is a way of digitally transforming manufacturing to help gain valuable insights into both the efficiency of a system as well as the ongoing maintenance of that system or process. Now, as Ricky pointed out, IoT employs a number of devices, sensors, various software, hardware, cameras. I mean, everything's there. Smartphones, smart tablets, smart everything in this day and age. McKinsey estimates that IoT applications in manufacturing are expected to generate $1.2 to $3.7 trillion of economic value annually by 2025. Now, I don't know how old that statement is. Seems like a big number to me, but it is here and it's going to be here to stay. In terms of AI, has also been around for a good number of years. It means different things to different people. But to us, AI is an umbrella term for machines capable of perception, logic, and learning. Now, there's two or three different subsets of AI. There's machine learning and deep learning with neural nets and things like that. I won't go into the explanation, but according to Deloitte, predictive maintenance alone, or predictive maintenance solutions alone, based on AI, expected to reduce factory equipment maintenance costs by 40% and generate the economic value of $630 billion annually by 2025. I mean, that's some staggering numbers that are all going to happen within the next sort of 3 to 4 years. In the markets we play in, there are 4 trends that impact machine controller requirements. I'm going to go through each one of these in more detail. But there's, the Fieldbus standardization for machine automation. There's machine or controller consolidation going on. There's optimizing IoT at the edge, as Ricky said. And then there's this IT-OT convergence and security. And I'll go into each one of these in detail. So Fieldbus standardization for machine automation. There are many solid standards around. There's Ethernet IP, there's Circos, there's Profinet, there's Mechatrolink, there's a whole bunch of them. In the past 5 years or so here in the US, EtherCAT has become a dominant player with more and more OEMs adopting it. So EtherCAT seems to be the winner here. And in APAC and EMEA, they're probably slightly ahead of us in terms of adoption of EtherCAT. But EtherCAT is definitely, we see it as the winner here in the US now as well. The second trend is controller consolidation. So you could have historically you would see a machine controller on one hardware platform, and maybe a vision controller on a separate hardware platform. So you have all these disparate systems that not only cost you extra money, but also they were typically not connected to each other. So they didn't talk to each other. So with the introduction of multi-core chips and the power of the PC increasing exponentially, it is now possible to collapse those different controllers onto the same platform, and the cost savings here are obvious. And many companies are starting to realize that now. The third trend is, and Ricky touched on this a little bit, is optimizing IoT with AI at the edge, as well as in the cloud. Edge AI, as you can imagine, gives you machine level insights, whereas cloud AI gives you plant enterprise level insights. By combining and using both, you can dynamically adjust machines and the entire factory based on actionable insights. A good example of this is one of our customers on their manufacturing floor at BMW. They have a single multiple production lines, but the same production line has multiple robots, has vision controllers, has a CNC controller, and they're all running on a single PC platform. This gives them the ability to quickly adapt that line from producing, say, an X5 to a Series 3 car on the same hardware platform. And this is simply achieved by changing the software required for each specific vehicle type. The fourth trend is IT-OT convergence. IT-OT convergence is the integration of information technology and operational technology systems. IT systems focus on data centers computing. OT systems focus on events, processes, and devices. The challenge is the IT folk don't really know how to handle the volumes of data on the OT side. And what we're seeing in the industry is an IPC with a Windows front end as the edge device, familiar with the IT, eases the IT-OT integration. So what we're seeing in the market here is the adoption of a COTS PC, an IPC or rugged PC with an RTOS is more than able to address the requirements best. So what that platform must have is it must be able to support multiple controllers on a single IPC. It must be able to support AI, both at the edge and on the cloud. It must respond to actual insights. And importantly, it's got to be manageable by IT for security reasons, etc. So an IPC with RTOS offers best edge device controllers support. So just one slide here on what interval 0 does. You're likely wondering what we do. Our flagship product is RTX. It's an RTOS that runs on a standard Windows PC. We support multi-core systems that allow you to run multiple controllers on the same platform. And with our Kingstar product line, we introduce an EtherCAT master, a motion control, or set of motion control libraries, a Gigi Vision module, and a soft PLC. All of the Kingstar products sit on top of our RTOS platform. They give you the deterministic processing requirements that these various applications might need. That's just what we do. And just three customer examples to punctuate that. In the ag industry, over the last sort of 5 to maybe even 10 years at this point, there's been a huge push for technology. And the ag industry actually lends itself well to technology because one thing that's driving that is the rising cost of labor over in California specifically. And also there's a lot of manual processes in the ag industry that actually lend themselves very well to automation. We have one customer who harvests, this is out in the Central Valley in California, and they do tomato harvesting. And they have two tractors. This is kind of unique, and so bear with me. It's a unique application. The two tractors, there's one tractor for harvesting the tomatoes and then another tractor for actually pulling the trailer alongside that harvesting machine. And these two systems, they have an IPC, a rugged IPC on each tractor. They're autonomous. They talk to each other, so they make sure they have the same trajectory, the same path, the same speed, etc. And they run side by side while one tractor is actually doing the harvesting. The other tractor is actually pulling the tomatoes for transporting to the factory. And the technology used there is quite incredible. They use our RTOS platform, RTX64. And then there's a whole bunch of sensors on these tractors, for example, for like header height control when they actually harvest the tomatoes themselves. There's sensors inside the trailer that actually speed the tractor up or slow it down, depending on where the tomatoes need to be placed inside the trailer. It uses LiDAR, IMUs, there's RTK GPS, and there's a good amount of machine and deep learning in the application as well. There's also machine-to-machine communication between the tractors, and the data, there's cloud data gathered for analytics to measure things like tons per acre, tons per minute, acres per hour. So that's a kind of a unique application for AI and vision. A more traditional industrial automation type application is we have one customer who is creating it's a machine insertion for actually creating credit card bills. And the technology used in that application is, once again, we're actually a combination of both RTX and Kingstar. It's a software-based motion control system. It's got a 500 microsecond cycle time. There's vision inside the application for barcode scanning of each sheet of paper that goes into the credit card bill. All these machines, or these sensors for mail thickness to confirm page count. Sensors for mail thickness. All machines networked for web access to factory floor, so managers know up to the minute status. And then there's also cloud data sent for motor, current, etc., for analysis of upcoming maintenance requirements. Just the last example. This is, once again, a traditional industrial automation example where it's a fiber laser cutting system. And as you can imagine, that requires deterministic processing. They use our RTOS for that. They use our Kingstar motion platform for servo control over an EtherCAT network. There's external conveyors, and they're run on the same EtherCAT master, so you've got multiple controllers on the one IPC. There's CNC software in there as well, and there's also a vision system for fiducial alignment. And once again, data there is captured for production and maintenance purposes in the cloud and on the edge. With that, I think I'm done, and I'd like to hand over to Tafiq.
Thanks very much. I'm hoping you guys can all hear me. So this is Tawfiq Ahmed. If I can forward to my slide here quickly. Just this one. Sorry about that. All right, so this is Tawfiq Ahmed. I'm a senior manager in the embedded business unit covering the industrial segment. I'd like to thank Dave for letting us be part of this presentation today. And then also Rick and Brian for a great presentation. So I don't want to obviously repeat a lot of the trends that's happening out there. It's already been discussed. So I'm just going to jump into some of the critical things that we at Micron are tracking in this area. So big machines, big data, not a surprise. There's a lot of industrial IoT devices that are being connected to the network. The numbers are growing exponentially. You've seen some of the forecast data previously, but this is definitely happening. We see this all day, every day. But the thing to bear in mind here is that the AI workloads is really complex on how to manage all this information. And I'll give you some examples as we go through the presentation. Another thing to note is that edge devices are becoming more intelligent. So the idea of making decisions at the edge is very important to a lot of people out there. We are Micron. We make our own products. We have our own factories, and we are definitely taking advantage of this scenario and making a lot of OpEx savings by doing so. But the other thing to note here is that end-to-end device security is also very critical as cyber threats increase. You generate a lot of data. It is your asset. You don't want to give that away to anyone, so you need to also be able to protect that data. And with the advent of 5G, it's enabling a different sort of deployment scenario where you can have a direct communication in real time for these billions of connected devices. So based on all this, what we are going to concentrate today on is kind of the edge side of things. As I mentioned, I covered the industrial side of things in Micron. The four areas that we are really tracking in terms of memory and storage requirements and growth are in smart infrastructure, surveillance, transportation, and medical area. In the smart infrastructure side of things, predictive maintenance and all sorts of energy asset and quality management. These are obviously very important, but a new area, not so quite new in the industrial side of things, but certainly in terms of how logistics and service area is being addressed by robotics solution is getting a lot of interest and traction. And after COVID, we are seeing a lot more deployment of robots to handle a lot of the tasks that are out there. I'll show, again, as I mentioned, we will go through an example of this in just a second. But at the core of this whole smart infrastructure is really the industrial PC. This industrial PC is kind of the building block. This is where all the edge computing and all the decisions are being made, and a lot of information being processed. Along with the industrial PC, there's this IoT Edge Gateway that is there to collect all the sensor data. And these IoT edges are talking to the local industrial PC, or even can transmit information by using 5G type connections outside of the factory. But irrespective of all that, because of the number of or the sheer amount of data that they are collecting, we are seeing tremendous growth in terms of the RAM or the cache requirements by about 2 to 3 times. And even the code is becoming more complex, so that's also increasing in terms of the size and requirement for memory and code storage. And then because there's a lot of data that you don't want to backhaul all the way to the cloud, you are storing it at the local device. So having a high amount of data storage to store the information and then maybe process it later when the time is more convenient, that model allows them flexibility to address the critical tasks first. So similarly, in the surveillance area, that's deployed across cities, retails, enterprise, home, we are seeing tremendous growth in smart cameras. But not only these smart cameras are just taking videos or transmitting video information, they are becoming intelligent. They're actually adopting AI in these smart cameras. And once they do that, the RAM or cache requirement goes up to about 8 times right now. 2 times code storage, and we are also seeing local data storage, and that's going up to about 1 terabyte. Edge servers that are connecting multiple or collecting data from multiple of these smart cameras are also growing. Transportation, I'm not really talking about passenger vehicles here. Obviously, passenger vehicles by themselves are going to adopt AI. And as we become more driverless functions and features over time and go through the different levels, in the transportation, in the industrial side of things, we are tracking autonomous fleets, drones, delivery vehicles, farming, trains, buses, etc. And they are also using AI for collecting the data through sensors and then processing and storing them in the local equipment. And no surprise, medical with the diagnostics, imaging, and patient management area, AI is absolutely a key function or key requirements in there to give you better analysis of what you're seeing and even get a lot more detail than a doctor can see today. So that again drives the requirement for GPU and DRAM and storage. Staying in the vein of kind of one of those smart manufacturers, smart infrastructure area, I'll use industrial manufacturing as an example. So endpoints being, if you are in a factory, device management, human-machine interface like an HMI panel, any visual inspection that you're doing through a camera, and even the robotics that are actually going around the factory have machine vision built in. Into the robots. Gateways we just talked about of what they do, and then also edge servers that are doing predictive maintenance. Ricky mentioned digital twins and generative design. Those are things that are happening. But alongside of that, we also have production chain optimization or supply chain optimization work going on through these edge servers. So where we see the future heading is that we are seeing increasing usage of AI that's going to lead to unsupervised learning, so no human interaction. Reinforcement learning, where you don't need a scientist to understand the data, it can be learned at the edge. Then also distribution and localized learning. So imagine you have multiple factories around the world. You can collect the data from each of the factory and how they're performing, learn from them, send it to your central node, and let the central node distribute across all the other factories around the world. So you can take advantage of the learnings from each of the different local factories out there. And as I mentioned, security of your data, privacy of your data has to be a zero compromise. This is your competitive advantage when you're deploying these systems, and you need to be able to secure the data and be completely trust that data is secured. So since I talked about robotics here a little bit, I thought I could just throw in a case study in here on an actual deployment. This is obviously, I'm not going to name any names here, but just wanted to talk about AI in manufacturing for robotics. These are obviously robots that are going in. They are freeing up humans to do other things. So just a disclaimer, I'm not saying that robot is going to displace human in the factory. They are there to help human to work much better, and the human or the manpower that is previously doing those tasks can be trained and upgraded, and they are now able to become the system managers who are dictating what needs to be done, but let the robots go and do the repetitive tasks out there. So how does an AI functionality help in this case? Well, if you think about robots, you'll have multiple robotic arms all over the factory. Somebody's taking the car door in an automobile factory. They'll make the car doors, lifting it up, putting it into the chassis. Some of the robots is actually carrying the car through the pipeline. So if you can go and program these robots and they can understand what they're lifting and what they're dealing with, that would be a great asset, because the robots can immediately understand, oh, am I picking up a box? Am I picking up a car door? Am I picking up a set of screwdrivers? Depending on that, they can adjust the amount of pressure they put on the robotic arm itself to actually pick up the object. It can also do optimization, so it can offer you motion efficiency. So one of the key parameters in any robotic deployment scenario is to see how they're moving. Are they moving synchronously? Are they moving to your specs that you created? So that make sure that they actually are following your guideline. And the more accurate you can be on that, the more savings you will have operational-wise to actually get the best out of your robots out there. And then also in terms of maintenance, AI provides predictive analytics so that you can actually see what kind of things are happening in case there's a degradation of some of the robotic arm. Maybe a motor is degrading. You'll be able to go and replace that as you need to. One of the other thing is that this is great. AI obviously is good for robotics. So why don't I just go and put it all in one in the robotic arms? So remember, in a factory, you could have 20, 30, 100 robotic arms doing each function. So if you go and put all these AI engines in all these robotic arms, they have to do the real-time processing. And when they're doing the real-time processing, they burn power. So as you can see, the power in here is going to go pretty high. So what can we do in this scenario? So the best thing to do is to consider a localized industrial server. So now you've located everything into this one server. It has multiple GPU cards. It can handle redundancy. You can do your development, qualification, and maintenance in one box. This can be also a bridge between OT and IT. But the key thing here is to make sure that you choose the right vendor who can offer you longevity, reliability, quality, endurance, and also AI capability that can handle the load. So I know I'm running out of time here. Just quick two slides here. We in Micron have been in this industry for a while. As I said, we have our own factory. We're taking advantage of AI. We understand, we have in-depth knowledge, a lot of broad portfolio from LPDDR, DDR, all these things that you're listed below that you'll need for a successful AI deployment. And then finally, I'd like to just mention that we are true believers in this area. We introduced a concept called Micron's Industrial Quotient, IQ value proposition, that addresses product longevity, ruggedized products, highly reliable products, and also products that are very high quality, and then application-specific features that help you analyze the data or takes advantage of special features to deploy them in this given scenarios. So hopefully that will give you some idea about what we do and how we can help. At this stage, I'm going to finish. Thank you very much and hand it over to Rich.
Awesome. Thank you very much. You guys were great. This is the time where we answer your questions. So as I said in the beginning, type your questions into the question box and we will answer as many as we have time for. If we do not have a chance to answer your question, someone will get back to you after we're done, so everything gets an answer. Okay, let's see. Where do we want to start? Who do I want to pick on first? Let's go with, let's see. I don't know who this would belong to, so you guys are going to have to help me out here. AI versus legacy, probability of detection and false alarm rate, performance, functionality. I think this person is asking, what are all of these things in this system? Okay, we're like in school where I got to pick on somebody.
I think Ricky was leaning forward, so I'll lean back and let him take that one.
Go ahead, Ricky.
It's one of those. It's one of those questions you're kind of like trying to figure out the meaning of the question. I mean, you know, I mean, the topic is around AI and IoT. So yeah, I mean, legacy systems and legacy solutions. You know, they've had data. It's not like data's not existed in the past. But I don't think it's existed in the same way or fashion that we're looking at now. So yeah, so when I look at legacy platforms and legacy technologies, you know, we want to, you know, accessing the data that sits inside those systems and pulling that out is important. And then obviously, I think complementing that with new capabilities as well. So if I'm looking at legacy machines and I want to, you know, they're part of the solution, maybe, you know, we talked about robotics and things like that, and robotics creeping into the factory. So I want to bring both of those aggregate data together and be able to do that. So again, it goes back to that slide I showed. There's many forms of data. So bringing all of those data forms together. So I'm not saying that the old was particularly bad and it's unuseful. Of course, I can get access to that data. As I connect new things and new capabilities, and I can abstract that data and put it into a format that I can do something with it and run these AI models. And again, the question kept coming out around compute. You know, if you're going to analyze data at the edge in near real time, you need heavy compute to be able to do that. So, you know, firstly, getting access to the data, then having the compute platform that's optimized to use that data, both legacy and modern data, and then getting outcomes from that data and optimizing the platforms that you're going to deploy it on. So I don't think there's a right or wrong answer to that question, Rich. I think it's all of the above. It's basically what we, as you know, inside Intel are looking at as we enable our partners and the community around that. So, you know, and, you know, again, I'll say one thing and I'll pass it over to the other guys. There's no such thing as you go from an old factory to a new factory. So, you know, there's this evolution. So bridging those systems, you know, and we've been working on these platforms that together with our partners that says, hey, how can you take a legacy platform, either through workload consolidation, move it onto a server, changing the software, bring these things together, develop that around what we call these intelligent edge platforms now. That's really what we're looking at, intelligent edge platforms that bring those environments together, both legacy and new, and then allowing you to make the right decisions on that from the data that you have access to in the time that's important. So, you know, I don't know if that fully answers the question, but that's kind of how I see this world between what's out there today and what's coming up as we integrate more and more devices, more and more cameras, more and more robotics. I don't know if the other guys want to add in on that.
Okay, I'm going to guess by the earlier silence that they do not. So I am going to pick on Dave here. Okay, Dave, what vision libraries does your Gigi vision driver support?
That might be, are you sure that was to me?
Yeah, they could be to me. This is Brian.
Okay, I thought that was to Brian. Yeah.
All right.
Well, so I mean, so as I said in my presentation, we actually developed a Gigi Vision driver. Now, in theory, I mean, you can use any vision library you want with our Gigi driver, but out of the box, we, as part of that process or part of that driver, we ported OpenCV to run on RTX 64 for things like edge detection, etc. Right? So, but in theory, any vision library would work.
Very good. Tafiq, you reference work in transportation, including drones. How can AI and AIoT play a role in unmanned traffic management systems?
Great question. I think we've been talking to drone manufacturers, obviously, and how they plan to implement AI in their system. So I think it is right that if you're deploying drones, if it's in a commercial zone, how would you go and navigate across each other and not bump into each other or other drones? So better traffic management is really to optimize the path finding and also making sure that you are following your path and transmitting to what we call the vehicle to infrastructure type communication, right? So you as a vehicle is communicating to infrastructure to let them know where you are. And then also proximity alerts that can be generated if vehicles get close together. The same principle can be applied to drones in this case. And then also kind of let them know when you started. So if you started from point A to point B, approximate time for how long the journey is going to be important. So as you can see, AI is extremely important in doing that. And in some cases, AI can actually give you time zones that you should take advantage of to make that journey in that allowed time frame. So hopefully that gives some clarity.
Yeah, I'm just going to add in there a little bit, Tafiq, as well, is, there's two aspects to drones as well. I mean, there's what the drone is doing and there's how the drone is acting in the environment. And both, to some extent, have an AI implication. Let's say, for example, we've been working on use cases where we're using vision-based systems connected to the drones that are flying over oil and gas or utility lines. And that, one of the things we saw in the US in California was, hey, trees are growing, they get near these power lines, and that causes wildfires. Well, can I use drone technology and AI to identify, hey, the type of tree, where it is, what's going on with the wind, and do I need to take a proactive statement to go out there and do something about that tree before it becomes a problem? So there's an example where you're using AI in the utility environment, from what the drone is doing. And then I think to what Tafiq said is a little bit, which is, so now I've got multiple drones. Well, how do I manage those drones? What are they doing? So, we can set flight paths and things like that around those things, but ultimately you need the flexibility of AI to kind of like say, hey, I'm going over something, I want to do this, I want to avoid that. So I think here's a classic example where we get layers of AI even in the environment. There's AI at the camera level, there's AI in the drone, and there's AI back at the control room. So you're seeing, how does AI not just appear in manufacturing, it's coming everywhere in everything that we do. And the compute power to support that, optimizing where do you want to run those inference engines, at the drone, at the back office, in the control, it's kind of everywhere, and it's going to be movable as well. That's why I kind of call this fluid compute environment that's going to exist at the edge where these things run.
Okay. Dave, what are the types of services Axiom Tech offers in addition to their solution platform?
Good question, Rich. Axiom Tech classifies its design either as a derivative design or a full custom design. A derivative design is some activity where we take an existing product and almost classify it as a reference design where we share design information with the customer, and they would ask us to develop a scope of work that would pull some of the design out or some of the features out of that design and add back their application-specific requirements. So that would be a derivative design where we're starting from an existing off-the-shelf product. The second type of design is a full custom design. And there, as it implies, we're pretty much starting from the molecular level under the guidance of the customer, working up a feature set, a scope of work, and finally a full-blown design proposal that might include electrical and mechanical design, including could be a baseboard design, could be a full-up custom design. It could be based on a standard form factor, or it could be, as I mentioned, the customer supplied architecture. On the mechanical side, we do full 3D rendering before we do any type of CAD. We do metal, plastic, full thermal analysis, shock and vibration, and finally, at the end, we will do a full regulatory certification, depending upon what country they want to market the product.
Excellent. Okay. Ricky, from the presentations, it is not clear how AI is better than legacy systems function-wise. I'd like to hear your answer to that one as well.
I mean, it's an interesting question. I mean, you know, and I've been in this game a long time, you know, so, you know, the question's kind of, I suppose in a way, you know, functionality wise, legacy systems were what we call appliances. So that appliance did something in the environment that it's working. It's optimized to do that, but it's very narrow. It only does what it does around that system. Okay, so in a sense, it's good at what it did, and certainly, I always say, you know, I plug something into the socket, the electricity comes out. It's not like things were broken. But what does AI allow me to do? AI allows me to take data from sources that are not just restricted to the one appliance and apply something. Now I can connect it to different things. I can connect it to external data sources. I can connect it to multiple internal data sources. I can start to see things that maybe that machine in that environment didn't have access to before. So I would say, you know, why is AI, I think, as we go forward, going to be much better? Because it's looking at data in a whole different way. It wasn't restricted to one area of the factory or one appliance or one system. It's something that you can start to pull out that data and aggregate across multiple areas. You didn't have the compute platforms that existed at the edge to be able to do that. Again, go back. You've got, you know, much more powerful machines now that can do that analysis at the edge. You know, you need to do it at the edge because you can't send all the data back. So again, functionality-wise, yeah, systems are working great. With AI, you can do much more. Manufacturing processes are going to be more optimized. You're going to get better outputs out of the factory. You're going to reduce downtime. You're going to be able to do different things as well. Imagine now I can connect AI into, you know, order fulfillment. So, you know, hey, how am I optimizing my factory around order fulfillment? These things were very, very cumbersome to be able to do. So think of AI as, it's kind of in a way, we're just tipping the iceberg today about what's possible with AI. We're just showing you very briefly into a few of what goes forward. Think about as you fuse in 5G, you add in things such as AR and VR and these other technologies with AI capabilities on top. So today, it replaces what's done. It's going to open a whole new possibility of opportunities as we go forward. And Tawfiq mentioned some of the things where he was going around. Shared learning. You couldn't do that before because you didn't have the systems to do that around being able to abstract data, analyze it, and share it from factory to factory through the cloud connectivity. So again, that's why I think AI is going to be much more powerful than what's out there today, because it's just going to open up so many different things that we can do, so many different optimizations and so many improvements as we go forward. It's a massive thing in Intel that we see appearing absolutely everywhere, and it's driving a lot of what we're doing on our platform technology.
You seem pretty passionate about that one, Ricky.
I really am, Rich. I honestly, AI, it literally, I mean, there's a lot of talk about it. Yeah, I get that there's a lot of concerns about it, but the potential here as we go forward is just going to be immense. I mean, I was working on AI systems 15 years ago with limited compute, and we were doing amazing things then. With the compute power that's available now, I mean, you want to see what we're going to do about sustainability and managing how energy is used in the factory environment. Right now, it's a machine that builds something. It's not aware of the power it's using. It's not aware where the power comes from. It's not aware of its supply chain. Put AI in the middle of that. I'm now building something based upon where I'm going to get power from, how it's going to be used, and how it's going to be delivered. Never been able to do that before. That's why I'm passionate about it. It has a massive impact on so many aspects of what we do today. Sorry, Richard, I can go on forever on that one. I'll let others speak.
Well, I would actually love to hear you go on forever, but I'm afraid we are out of time. As I said before we started, if you ask a question, I know there's a whole lot of questions here that we didn't have time for. Somebody from one of the companies will get back to you. A brief reminder that all Open Systems Media webcasts are copyrighted and may not be recorded without prior permission. So I'd like to thank our 4 speakers for great presentations and handling these questions. I'd also like to thank our sponsors, Axiom Tech, Interval Zero, and Micron for sponsoring this event. And of course, we can never do any of these things without you, the engineer. So I thank you all for attending, and I hope everyone has a great day.